Alright folks, in this video we're going to take a look at how we are dealing with efficiency and how we can rearrange that formula to let us solve a problem like the one we're seeing on the screen. So the first step, we'll go ahead and do a quick review of efficiency calculations. The second step, we'll talk about the problem. The third step, we'll go ahead and start solving it. So the core ideas to remember with efficiency is that if we take the output of a value, divide by the input of a value, multiply that by the 100%, that gets us efficiency as a percent value. Okay. So the other core thing to remember about efficiency is whatever unit you put into attached to your output needs to be the same unit that you're connecting to your input. So if we're dealing with joules in this problem, we know that that joules output needs to be over joules input. Okay, we can't have different units there. Same thing if we're dealing with watts. Watts of output over watts input. Or, since we've talked about how money can be tied to efficiency, we know that the output needs to be over the cost input. Okay. Generally, your input values are going to be the larger whole complete numbers. The output is going to be some smaller portion of that. So generally, when you divide these, you're getting a decimal value less than 1. Okay? That's why we have to do the multiplication of 100. So keeping the units just in mind as we move forward, we can now go ahead and start unpacking the whole problem. So what we're looking at, and we'll go ahead and highlight it as we're going through, is that we know that a TV is converting 2,000 joules of energy into something useful. We could consider that the same as the output. Okay. We also can see that we have a 60.8% efficiency and that we have to calculate the output. Okay. And in doing the calculations, it's telling us that our unit needs to be in joules to 1 decimal place. So those are things to kind of keep in mind as you get to the final answer. So what we do is we start connecting the data in the problem to the problem and the equation itself. So we know that the 2,000 joules goes down to our input, our efficiency of 60.8 is going to go over to the efficiency calculation. So we can go ahead and write out these values. So we don't know output yet, but we know that we are dividing by 2,000 joules, multiplying by 100%, and equaling 60.8%. Now, keep in mind with mathematics, you can do all sorts of different order of operations as long as you're still doing the same thing on one side of the equation to the other side of the equation. So the way that I'm going to start is I want to go ahead and recognize that we need to isolate the output. Everything else on the left side of the equation needs to go away. So to do that, we can group these together. This is why I like using parentheses in a lot of these problems. And we can divide both sides by that 100%. And what happens is that on the left-hand side, the 100% cancels out entirely, the value and the number. And on the right-hand side, the percents cancel out. And because we know that with dividing by multiples of 10, we can just move the decimal around. And in this case, we'd move the decimal place over 2 spots. Okay, so we can rewrite this as the output divided by 2,000 joules equals, in this case, I'm just going to go ahead and leave the, actually I'm going to go ahead and mentally simplify it down, so we know that it's 0.608. Okay. What's left is on both sides we now need to multiply by 2,000. So we multiply by 2,000 joules, multiply by 2,000 joules. Same thing occurs. We know that joules and the whole 2,000 cancel out on the left, leaving with just our output. And on the right hand side, this is where we can go ahead and pull out a calculator. And we can take the 2,000 times 0.608, and that leaves us with an output of 1,216 joules. You'll notice no decimal points in there. This is a pretty clean calculation, but even if we had the decimal point in there, we'd basically be saying it was 1,216.0 joules for our official answer. So hopefully this helped you kind of remember the ways that we can rearrange our equations when we have a known value on one side but missing information on the other. And as always, if you're needing more help with these calculations or the ideas behind efficiency, feel free to leave comments down below, send me a message, or ask me for those of you in my classes. So as always, take care, and I will see you later.